principle for the fluid in equilibrium is the Archimedes principle for the buoyant force. Okay, it gives you the way to calculate buoyant force. Archimedes principle says that an object completely or partially submerged in the fluid is buoyant up by a force, buoyant force, with magnitude equal to the weight of the fluid displaced by the object. Okay, it gives us a simple way to calculate the buoyant force. So it says that the buoyant force B equals to the weight displaced, the weight of the fluid displaced by the object, and the weight equals to the mass of the fluid multiplied by G, right? Displaced fluid. And then this is the density of the fluid multiplied by the volume submerged or displaced multiplied by G. Okay. So this is the equation to calculate buoyant force. Please note the two substrate here, fluid and submerged. Okay, be careful because if you are not careful, you may put the density for the object. The buoyant force is calculated from the density of the fluid, not the object. Okay. And the submerged here is important because, okay, if the object is completely submerged, so this volume is volume for the object V. But if it's just partially submerged, so the needed volume should only be this part. Okay, that's the volume submerged. You cannot use the whole volume V. Any question here? So this is the buoyant force. Please note that the buoyant force is not actually a new force. It's a force comes from the pressure change difference we calculated from there. You can think about if you have some object, let's consider something completely submerged. So here it will feel some pressure from the water above it. And it feel pressure from the water below it upward. And since this pressure at a more deep place, so this pressure is actually larger than this pressure, right? So the upward force is larger than the downward force. Okay. This pressure difference produces the buoyant force. That means if you are already talking about buoyant force, then you shouldn't talk about the pressure difference. Okay, so sometimes students may talk about both at the same. It says when you do the first analysis, you say, okay, there is some pressure difference and there is buoyant force. No, you cannot put them both at the same time because they are the same thing. Okay. Any question? Okay. So a related phenomena is called the apparent weight. If you measure the weight of an object in the water, the weight you measured, which is called the apparent weight, will be smaller than its true weight due to the buoyant force. Okay, I guess you never made it, but you feel it. You can feel it. It's very easy to hold a heavy object in the water, right? Because buoyant force can help you to support it. So the apparent weight is the true weight measured in the air or the vacuum. Okay. Subtract the buoyant force in that fluid. In fact, precisely speaking, when we measure the egg weight in the normal condition, we are also measuring the apparent weight in the air. Air is fluid, so air has some buoyant force. The true weight, precisely speaking, you have to measure it in the vacuum. Okay, when there is no buoyant force. But since the air density is very small, so most gas the density is small. So in that case, we can roughly speaking, the weight we are measuring is the true weight. Okay, so the weight measured in the air we regard it as true weight. Okay, in this class at least. But if you measure the weight in some liquid like water, oil, the difference will be very large. So you have to distinguish the true weight and the apparent weight. Okay? Now, let's think about which object will sink or float in the water. Okay, let's talk about water. So, of course, we know that if you have water, you have the iron block and the wooden block. You know, the iron block will sink down, the wooden block will float up, right? What is the reason? How do you explain this? It's very common for pupil students, okay, in elementary school, high school. They explain this, they will say, because the buoyant force for the iron block is larger than the buoyant force for the wooden block. Is it correct?
No.
Think about that.
Technically, wouldn't it be a little bit correct because the wood is submerged?
So, I give you like this. If you have two blocks, one is iron, another is wood block. They have the same volume. This will float up. No, this will sink down. This will float up. Okay, we know the phenomenon. But let's try to explain the phenomenon. Many would say, because the buoyant force B1, let's call it B1, this is B2. Many would say B1 is smaller than B2. Is this correct? Okay, if it's not correct, why this one float up, this one sink down? In fact, the right answer, now we should know what's the relationship between the buoyant force B1 and buoyant force B2.
They're equal?
Okay, equal, right? If you
Same
look
order.
at how to calculate the
They're the
buoyant
same
force,
much.
you will know why they are equal. Fluid are water, both are water, density are the same. Submerged force, if you put both of the inside of the water and release them, and they have the same volume, so this is the same. And G is a constant. So the buoyant force B1 equals to B2. Then how come this float up, this is sinking down?
So, density of the object?
Let's think about force. When you say this one will move up, this one will sink down, which force you should look at? What kind of force you should look at? Net force. That's the key. To determine the motion of the object, it's up to the net force, not just one force. So here, for each object, you have two forces, right? For this one, you have the weight and the buoyant force. This one also have the weight, W2, W1, the buoyant force. Okay. The net force will determine, or the combination of the two forces will determine the motion of the object, not just the buoyant force. So what many people may make mistake is that they only look at the buoyant force, forget the existence of the weight. What happens if you compare the weight, W1 and W2, what can you say? The weight of the iron and the weight of the wood. Okay, now can you see why even with the same buoyant force, this one will sink, this one will float. How to explain it? No.
Yeah.
For this one, what is the direction of the net force?
Down.
Hmm? Net force.
Net force makes it.
Okay,
sink.
in fact, you can even know, since W1 in this case larger than B1, for the iron, the weight of the iron will be greater than the buoyant force. So the net force is downward, right? And for this one, the weight is smaller than the buoyant force. Okay, so the net force is upward. Okay, so that's the reason. You need to compare the weight and the buoyant force. So for both objects, buoyant force will be the same, but this one has a larger weight, this has a small weight. So, okay, so the net force for this looks like a larger force subtract this is B2 and this has a W2. Okay. So the net force is downward for the iron, net force is upward for the block. Okay. And then some of you mentioned to look at the density. So we know there is a simple criterion to judge the floating and sinking down of the object. You can compare the density of the object with the density of the water. The density of the iron is larger than the density of the water, so it will sink down. The density of the wood is smaller than the density of water, so it will flow up, right? And in fact, it comes from the force analysis. Because finally, it will be ended up with to compare density only. Because the weight, you can see, it's density. So if you compare the weight and the buoyant force for a completely submerged object, the buoyant force is, let's say, some object in the water or fluid. Okay, so it will be raw fluid multiplied by the volume multiplied by G. If it's completely submerged, so that's the object volume. And for this one, W is mg. So it can be written as density of the object multiplied by volume multiplied by G. That's the weight, right? This is mass M. So you can see they have the same G, same V. So the only thing you need to compare is the density of the fluid and the density of the object. So you try to compare the weight and the buoyant force. Okay, now let's think about another issue. Now, most of the ships and boats, they are made with iron or steel, right? Which has a larger density than the water. But why don't they sink down the ship? Okay, so in fact that's a problem troubles Asian people. They never think about they can make a ship with iron. They think that they can only make ship with wood. But actually, you can make ship with steel and iron. And the reason here, of course, you know it's determined by the fact if you graphically. If you have a solid block of steel, it will sink down. But the ship is not solid, right? It's something like this. So it's empty inside. So when we compare the density of the object to the density of the water here, fluid, okay, we're not consider the density of the material. We need to consider the average density of the boat. In this case, it should be averaged from the density of the steel and the density of the air. The density of the air is small, right? So it's possible the average density of the boat is smaller than the fluid density. Okay. So it's still the same principle. You have to make the object density is smaller than the fluid density. But it's not, in this case, the object density is not the same as the material density. It's the density averaged from the material density and the air density. If you can make it a vacuum, it's even better, right? Okay, so that's how you can. Or from another way you can think about it is that if you have something like this, okay, so let's look at this one. Okay, then make another graph. If you have some boat like this, to calculate the volume here, to calculate the weight of the object, the volume is this, right? To calculate weight, but to calculate buoyant force, please note the volume is this. So the displaced volume here, in fact, is much larger than the material volume in this case. Okay. So it can make larger buoyant force. Okay, and that's why if this happens, the water go inside, and then the ship will sink down because it doesn't have the air inside to make it density small. So it's just like an iron block, it will sink down. Okay. And for the submarine, that's a way it can control the motion of submarine, float up or sink down. It has some empty container. It will either put the air or water inside. If you put water inside, will make it heavier, so it will sink down if the weight is larger than the buoyant force. If it pump air inside, okay, so it will flow up. Okay,